Hi guys, welcome to this on-demand lecture. This week is a lecture in the continuation of our climate change series in the 21st century and related issues, including hazards, although I've been very broad from the start. And this week is the lecture on the Anthropocene. So if you click on the Anthropocene on top of the webpage, you're getting to that page here. And I will invite you to read the forum geography part. So that's a very simple text I wrote with some colleague of mine. And you can see Imaike Tailo Kimatsu Imali Poshimizu were students, who were students at my laboratory. And we talk about climate change and Anthropocene, the number or the increasing number of publication on the topic, and presenting some of the issues related to that. So we have here a case in Christchurch where we had an earthquake, so the land went down, so it created a relative sea level rise. And we look at how the sea level rise, even if it was sudden, which is not going to what we are going to experience all over the world, it's going to be more gradual. But what could be the issues that we'll be facing and how the land system interacts and are affected by climate change. So the data you have in front of you is a LiDAR data set. And we looked at areas that are floodable using some different model based on the base level of the sea. This is the result here of a simulation using an American model, which is called HECRAS, that has been created by the American Army of Engineers, the US Army of Engineers. And we can see actually the discharge and the height of the banks. And what you can see on that graph is that, well, the discharge is going to be more than often above the bank level. And when you relate that to a simple simulation using the diffusion model, at least for the sediment, you can see that you get erosion down towards the sea and accumulation inside the river. So it's not a good news when you are in those areas. So around here, we are going to have eventually more erosion and deposition somewhere in those rivers. And then explain here some of those processes. In Tokyo, then we zoomed on Tokyo and some of the issues we have there with climate change and the Anthropocene and what it means for those new shorelines. And here we look at the flood depth data, still from LiDAR data, and try to understand what it means. Where are the areas where we are at risk of having flooding with the increasing level of sea level rise? And one of the elements I put forward here is how actually the human evolution in those areas is also one of the factors that contribute to that problem. So when you look at the old historical map of the 1850s and 70s in Japan, well, you have those mud flats here of several kilometers, which are just now built on the sea. So we are not only very close to the sea level, but those areas those were areas where we had a buffer against strong winds and strong, when I say wind, it's wind and waves, and all those buffers are gone. So when the sea level goes up, there is nothing that's going to pound those walls, and that creates also erosion, which in turn has some negative effect or rapid negative effect on those areas. And then this is the Christchurch earthquake issue. We look at the coastal cliff retreat and what it means when you combine that with sea level rise. Another topic we glided through in this paper is also the problem of sea level rise, human reconstruction of the coastline, and how the tsunami is inundating those areas. You can see very clearly on that drawing here, it's a photograph, sorry, the role of the human road stopping actually the sediments. All of that has been flooded by the tsunami, not on that side, so you have the road having an effect there. But also when you are close by, you can see the road which is there There is little erosion on that side, on the seaside, but the Uzu, the maki at the back, have been eroding the sediment just behind. So the road here is very different. And then for those of you like me or some of my colleagues who work on sedimentology and old sediments, well, it's very interesting to see that actually contemporary sediments are also record of human life. And that's when we can start talking about the Anthropocene, because sediment records start to be recording also human artifacts. So I'll show you some other elements. Those are some elements on the Tohoku earthquake and tsunami. I will let you read about those. Okay. And then there is here a mural for the discussion. So when you are doing this lecture on demand, choose some space and try to organize your ideas around this diagram. And it's about climate change and hazards. And based on that reading, how do you articulate the different ideas, how the Anthropocene, the climate change will work together to actually modify sediment records, hazards, and the environment as a whole. So there is enough space, I think, for everyone without you having to fight for a location. But if you want to, you can just reproduce and copy paste that diagram and make another one if you want more space. And then there is the time series with pandas. So this time to avoid the problem I had with last time. So last time when I was using my dear Python, something happened is that after creating your lecture, I installed new libraries because I was doing some AI programming for myself. And unfortunately, those libraries I installed do not work with the libraries I used with you. And I had no idea when I saw those long series of errors coming out. I was like, what the hell? I was not that polite, actually. It was a bit more. And at least when we use the basic libraries, we can use Google Colab. I know some of my colleagues use it, so I went with Google Colab. If you click on it, you're going to go to your favorite Colab sheet. And this week for Python, for this lecture, I invite you to go and have a look at the river.1 go.gp.dat.deload. So I'm loading that data set. And you can see here, those are the river and rainfall data sets at different locations in Japan. And if you go back up to the parent directory, you get to that web page here. So the normal way to go through data is to choose cheese toka, cheese de yaru no wa ichiban kantan. So you click on the map and you zoom and you zoom and you zoom, and here we have zoomed on Kobe, of course, just for the pleasure of it. And you have different stations, and those stations here you can see in blue. The stations are the rainfall data. The triangle orange data are the water height, the stages. Suichitsu is going to be what's inside the water. And then you also usually have, for the triangle, you also have Ryuryo, which is the, how do you call that? Discharge, and other elements and data on the dam. So you can choose and pick the one you want. So if you go to local, for instance, and you click on that, you're going to see the station data. And you're going to have, like, let's say, the monthly rainfall, yearly rainfall. And let's say we use monthly rainfall, and you're going to have the data when they were recorded. So we have data from 2004 to 2019. And if I choose 2000, let's say 18 December, I'm going to get that data set, which has a few rainfall here. December is not a good month for rainfall. Let's choose June, where usually it's a bit more rainy. And when you look at the graphic, you're going to have two different elements. So maybe I went too fast. When you click on top here, you can look at the data as data itself, or you can click on the graph and get the graph. And the graph shows the cumulated rainfall as well as the daily, it's hour rainfall in millimeters per hour. And you have this data set here. So these data sets that you can see on my graph, which are just numbers, this is where I got that link here. So if I click on that again, and I click on one of those that file, I'm going to have one of those type of data sets. So here for each day, there is only one data, but you have data set where you have more data. So the question is like, how do you get to some of those data sets? And in Panda, you can then import Panda as PD, and you can just read the table straight from the internet. You don't have to download it manually. You can just go to your favorite one. And let's say, if we choose, I don't know, I want one with a bit more column, like this one, for instance. It's a bit more fun to play with. So if I copy, so I had here one data set. You see here at the end of the deload, I have the name of the file. So if I replace that file, and I tell it encoding Unicode escape. So the end of the code here is because it's encoded in Japanese. So when you have some Japanese names like this, yeah, blah, 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 blah. Usually Python and not Python, but the Unicode coding will not recognize it. So when I come here, when I specify which coding it is, Unicode, I will choose Unicode escape. So you know Unicode. And it worked the other day. Let's see if it works now. Okay, and it worked. So you can read that table to X. And what I've done here is just to make sure that I have a saved version of it, because I'm going to play with it. I just call it x2 equal x. So I have x2 in memory somewhere. And you see x, this is the data that we have in memory. And we have a lot of, I was going to say something wrong, a lot of different elements at the top of the table. These are the heads and they are in Japanese. We don't want that. We don't need that for the data set. So if I go down, and that was my first question, I don't need the first 8 rows of this data file. I would like you to remove those first rows. How should I proceed? And then there is a series of questions going down and down. So I'm going to do the first question with you if you want to. And then I will let you do the other question on your own. So for this one, there are different ways to do it. For me to get this and get rid of the first line, what I will do is to look at my file, and you see I have 1, 2, 3, 4, 5, 6, 7, 8 rows. So the 8 first row, I don't want them. So what I want to do is to get rid of the 8 for first row. So I'm going to create a variable, let's say n, which I'm going to put 8. So those are the 8 variable I'm going to get rid of. And what I want to do is to then look at my table and say, I want that table, but those. And for that, of course, there is a function. There is a function for everything in Python. So you go to x equal, and it's called xilloc. So if you do x.illoc, and then you define n, and then not of the rest. So that's going to do the job. This is going to remove the n first column, n first rows, sorry, of your data set. So if I do x head, and that's what I've done here, x head. So the x head, the head function for Python Panda, when you have a Panda data set, the head is going to give you the title and the first few lines. So you don't have to print out everything. If it's a very, 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 very long data set, like you have with big data, it's going to crash your computer eventually to try to display everything. So you don't want to do that. And let's see if it works. And it doesn't, because it tells me, and oh, I know what I did wrong. It's not a function. And let's start again. Okay. So I get those 8 first rows here. which are taken out. And because my rows start at 0, I've taken out basically 0 to 7. So I'm still back with my number 8, which is not what I want. So what I'm going to do is to take one more row out. Okay. So now I have all my rows, the one starting at 9. So the 8 first rows are all gone. And now the second question I'm asking you is like, how do you actually rename those columns? Because you see we have a column name here with all the data. So we're going to look at things later in details, but it still says blah, 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 something. So what I want to replace is to replace that by, well, those are the rain data. So what I want you to try to do is to use the rename function. So you're going to have x.rename, and you see it's coming out, which is a good sign. So in Panda, when you have you're using a common in Python in general, in that environment, you're using a common feature, a common command. You're going to have some options popping up, and then you use something, and I will let you decide on what it is, and we will look at all of those together once it's done. Okay, so that's how I want you to go through it. And if you have any difficulty, what you can do is just go to xrename. Okay, so I don't know how to do it, so I go here, xrename. I ask my best friend Google Sensei, and he's going to tell me pandas rename column index and data frame. So blah, 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 blah. How do I use rename? Oh, here we go. So we have df new here, which is going to be the new variable. And to that variable, we decide from the previous variable, df. Now, usually people work and do example with Panda. They use generic variable name as df, but for us it's x. And we want to rename a column. So we're going to say column equal and something, something. So column A would become column that's the new name we want to give it. And you will see that this one here, index row 1, might not be necessary in our case. But here we go. So, and then you have the example here, the column 1. Or the column A was renamed the column 1. This should be the, oh no, sorry, that's the new one. So that's the new variable with column 1. And when you print df, the original, you can see it's A. So A has become column 1. Okay, so I will let you work through all of this. I wish you good luck with all of those. Make sure that you work through all of that. If there is any difficulty and you just don't find it and it's not working, don't worry, we'll do it together, providing that I can make it work as well, not like last week. And I will see you then in, actually me, I will see you in 3 weeks' time, because we have 2 weeks which are online. And next time, the following one, November 2nd, it's going to be a colleague of mine who will be talking to you. It's Dr. Balaz will be talking to you about climate change, long-term climate change, and multi-hazards. So I will come back with you on November 9th, but you still have a lecture on November 2nd. Also, the way it's working is that we're going to go back to face-to-face lectures, but I'm aware that some of you are not on this campus. So what I will do is to record the videos, or at least try to have it on Zoom, so that we can have and the face-to-face and the online system working together. The only thing I'm not sure about is that where should I start? I'm trying to move stuff out of one of my own room, a research room, so that I can make it a space for learning for 4th year and people who are not fully in my lab. And I have to move those stuff out to another place. But I'm in the field this week, next week, so it's not going to happen for the 2nd, meaning that I will have to use a regular room on the 2nd. But on that day, I'm not quite sure I'm going to be able to use Wi-Fi or anything. So if there is no Wi-Fi, it's going to be a pain in the a bit of a pain for that lecture. But the others, I will try to make sure that we have both a recording, so you can watch it on demand, also through the Wi-Fi, like now with Zoom, so that even if it's in a class setting, you can watch it from whatever location you are on campus or at home. And I will do it then in your classroom. So those of you who want to have a bit more interaction and be in the class with the others, you can come. I advise you to come only if you have been vaccinated with the 2 vaccines, just for people like me, the old men who can die quite quickly, and also for your classmates, just by respect. So make sure that you respect that as well. And that's about all. So I wish you a good week. I will see you next week. And make sure that you do the work. Or before I leave you, that's the first Anthropocene lecture. And then we'll have the collaborative lecture. So collaborative lecture 1, which is this part, week 1, with the mural space, will be for you on the October 26th. And that's week 2 will be for us to do together on November 9th, after the lecture by Balázs Bladák. So this week, 19th, Anthropocene. Next week, 26th of October, week 1, divide yourself in group, blah, blah, blah. It's an exercise, a group exercise. Then on the 2nd November, Balázs Bladák, and then on 9th of November, week 2 of this workout here. This exercise here, just let me, before I leave for good, this is a group exercise. One of the things I recognize is that we are not very good at working together as a team, as scientists and practitioners and policymakers. And one of the reasons for that is that we don't do it so much when we are practicing at university and training at university. So for climate change research, I think it's important to be able to work as a team and recognize everyone's strengths and build on those strengths to get some interesting results. And that's what I'm trying to get at here, more than anything else. So I hope you enjoy it at least. And I will post that video now so they can have a look at it. I will give you also a link through Learn so that you can watch it whenever you want. Okay, so have a good week, have a good 2-3 weeks, and I will see you after that.